find the sum of n terms of this given series, where 2n plus 1 by 2n minus 1 is common in all the terms, and we are going to suppose this to be our x, for x not equal to 1, right? So let's start with the solution. Let x is equal to 2n plus 1 divided by 2n minus 1 for x not equal to 1. Let's write this complete sum to be as s, which is equal to x plus 3x square plus 5x cube up to so on. The last term becomes 2n minus 1 x to the power n, and let me also write the second last term, that will be 2n minus 3 into x to the power n minus 1. Is it okay? Fine? Yes? Okay. Let me multiply x on both the sides. Then we get xs is equal to x square plus 3x cube plus 5x to the power 4 up to so on. This is 2n minus 3 x to the power n plus 2n minus 1 x to the power n plus 1. Let's mark this equation as 1 and this to be as 2, and subtracting now 2 from 1. 1 minus x into s is equal to, so this is x plus 3x square minus x square is 2x square plus 5x cube minus 3x cube is 2x cube, so on. We get 2x to the power n minus 1 plus 2 into x to the power n minus 2n minus 1 into x to the power n plus 1. So we have subtracted 2 from 1. This is nothing but your GP series, the finite GP sum, and that is equal to a into 1 minus the common ratio to the power n divided by 1 minus r. Now here a is 2x square and the common ratio is x, right? And the number of terms are here n minus 1. So I'm going to use the formula for the finite GP. So this is equal to, the left hand side is 1 minus x into s. So writing the first term as it is, plus writing the finite GP sum, that is 2x square into 1 minus x to the power n minus 1 divided by 1 minus x. And writing the last term as it is, that is minus of 2n minus 1 into x to the power n plus 1, right? Okay. Further, I am going to take x divided by 1 minus x common from all the terms. So the first term becomes 1 minus x plus 2 into x, 1 minus x to the power n minus 1, right? Minus the third term, that is 2n minus 1 x to the power n into 1 minus x. So this is further equal to x divided by 1 minus x into 1 minus x plus, multiplying this 2x inside, so this becomes 2x minus 2x to the power n, right? And then also multiplying this term inside, so this is 2n minus 1 into x to the power n plus 2n minus 1 into x to the power n plus 1. So this is x divided by 1 minus x into 2x minus x is x minus 2x to the power n, and also multiplying this x to the power n inside, so this is minus 2n x to the power n plus x to the power n plus 2n minus 1 into x to the power n plus 1. Fine. Okay. Now minus 2x to the power n plus x to the power n becomes minus x to the power n. So this is x divided by 1 minus x into 1 plus x, and taking minus x to the power n common from these two terms. So this is minus x to the power n into 1 plus 2n. Or it can be written as 2n plus 1 into x to the power n plus 2n minus 1 into x to the power n plus 1. Is it okay? Fine. Alright. Now the left hand side is 1 minus x into s. Let's get this 1 minus x to the denominator of the right hand side. So this becomes 1 minus x whole square. And now putting back the value of x from here, that is 2n plus 1 divided by 2n minus 1. So s is equal to x divided by 1 minus x whole square. That is, x is 2n plus 1 divided by 2n minus 1. So x 2n plus 1 divided by 2n minus 1 divided by 1 minus x whole square. 1 minus 2n plus 1 divided by 2n minus 1 whole square. Let's solve this denominator. So this is 2n minus 1 minus 2n minus 1 divided by 2n minus 1 whole square. So this 2n cancelled out and we get minus 2 in the numerator. That becomes, because of the square, that becomes 4 divided by 2n minus 1 whole square. So the denominator is 4 divided by 2n minus 1 whole square. So 2n minus 1 cancelled out with this and we get 2n minus 1 into 2n plus 1 divided by 4, which is also equal to, this is a minus b and a plus b. So a minus b and a plus b, that becomes a square minus b square, that is 4n square minus 1 divided by 4, right? So this is 4n square minus 1 divided by 4 into 1 plus x. So this is 1 plus 2n plus 1 divided by 2n minus 1. Then is minus 2n plus 1 into x to the power n. So minus 2n plus 1 into x to the power n. That is 2n plus 1 to the power n divided by 2n minus 1 to the power n. So the numerator becomes 2n plus 1 to the power n plus 1. Right? Okay. Then is 2n minus 1 into x to the power n plus 1. So plus 2n minus 1 into x to the power n plus 1. So x is 2n plus 1 divided by 2n minus 1 to the power n plus 1. 2n minus 1 into 2n plus 1 to the power n plus 1 divided by 2n minus 1 to the power n into 2n minus 1. So this cancelled out. So this is equal to 2n plus 1 to the power n plus 1 divided by 2n minus 1 to the power n. So the terms are very beautifully simplified and these two terms now cancelled out and we get 4n square minus 1 divided by 4 into, okay, let's solve this. This is 2n minus 1 plus 2n plus 1 divided by 2n minus 1. So minus 1 cancelled out with plus 1. So this becomes 4n square minus 1 divided by 4. And here we are getting 4n divided by 2n minus 1. So this 4 will go. So I can write 4n square minus 1 to be as 2n minus 1 into 2n plus 1. And here I am having n also divided by the denominator 2n minus 1. So these two cancelled out and we get n into 2n plus 1. So this is the required sum to the given series. Alright, thank you.